Hi everyone, Twoneurons here, and sorry for the delay between my most recent video and this one. I know it's been some time, but as some of you know, some things have gone on in my personal life and work life that have eaten my attention up. That said, I plan on returning by making a series of these quick videos like this one on simple targeting, another video on how to do a heat seeker missile, grappling hooks, and a less than simple save system. So this is the first video in that series, and in this video we'll be creating a simple targeting system. That said, open up your project that you want to put a targeting system in. As long as there's an enemy class in there, we can work with that. Or start a new third-person project and set up some simple chase logic for your enemies, that is. That said, I'd like to thank my Patreon sponsors for helping make this series possible and keep this channel alive, like Random Number Generator. That said, fire up your editor and let's get started. Hey everyone, and welcome to the editor. So as I mentioned in the start of this video, we will be doing a simple lock-on system. I'm going to quickly show you what that system will look like. As you can see, I have a few tests that I've already put in, and I'm going to show you, as I said, what will happen. So first, the enemy will locate the player, and it will chase them around. I'm going to let him chase me into this area. There's no nav mesh out here, so he'll stop chasing at a point, and then he'll start running back to their start location. Now, you don't need any of that. The idea of this system is you should already have your own enemy class that you're working with. And now I lock on. You can ignore the debug sphere. You can see that I'm locked on to him. I can't move my camera. If I run out of the range, well, we're unlocked again. We're locked back on. I ran out of range. There we go. Well, nav mesh issues, but that's besides the point. Still locked on. If I do that again, I unlock. So we're going to create this system. To do this, you will need your own enemy class. I'm not going to go over how to create a chase system in here. If you're interested in that, go ahead and watch my AI tutorials. There'll be a link down in the description. So all you need to start is a map area you're going to use. So I've used a third-person template map. I've changed this wall so it's shorter, and I extended out the walkway a bit. But I've only set the nav mesh to cover this interior area. And that's just so I could very easily get far enough away to break the nav lock the target lock to see if that system works. Okay, so first thing we're going to want to do is we're going to create a widget. You see I have my test here, so I'm going to create one for you guys now. And we'll use my normal naming convention of widget blueprint, WBP, Target Widget is what I'll call this one. And let me just move this into the correct screen. So this is a relatively simple thing. All we're going to do is we're going to change the screen size here to desired. And we're going to take an image and we're going to drag it into the canvas panel. Select the image, and I'm just going to rename this for good practice as target image. And we are going to want to size this to content. So right now it'll come a little bit smaller. And we're going to find our recording indicator. Now, if you type in record and it doesn't pop up, nothing pops up, it's still there, it's just hidden. What you have to do is go back to your main window and under your content browser, click view options and make sure you have show engine content selected. If I turn that off, go back here, select my image and type in record. I can't find it. View engine content, record. Now you can use any indicator you want. You just need a transparent background so you can see through it, or some transparency so you can see through it. So I have my image. I like the size it's at. I don't want it tiled, so I'm not going to change that. Everything else in here is correct. That's all I need. I'm going to go ahead and save that, and then I'm going to go over to my enemy. Now, enemy AI follow is the base class I'll be working with. Now, I'm assuming you're going to have good inheritance and have an enemy master class and then several sub-components or sub-classes that are the individual enemies, from humanoid enemies, flying enemies, what have you. So just assume this is my parent class. I'm going to pop it open, and as you can see, this is all my follow logic and stop chase logic and a whole bunch of other things. We don't need to worry about any of this. You can completely ignore all of this. Let's go to our viewport for a moment though. Now, in our viewport, what I'm going to do is I'm going to add a component. I'm going to type in widget. And I'm going to name this my Target Widget. Now, ignore the fact that I have walk selected there. I was playing with the speed. I'm going to select my Target Widget. And in my Target Widget, well, first I'm going to compile and save. Sorry, I'm just getting these all back open. I want under user interfaces, I'm going to set this to screen. You don't need to worry about that. Then under my widget class, I'm going to take my Target Widget, and I'm going to set its size to 50 by 50, just so it's a bit smaller. I'm going to have enabled, and sorry, I'm just trying to find one thing. There we go. Under collision, I do not want to generate overlap events. Under rendering, I want hidden in game. Okay, so with that done, what we're going to do is we're going to go into our main content folder here, and so let's go to targeting. I'm going to create a new folder, and you can tell I didn't do the test of this. I used a different method, but this will be my interfaces folder. And in here, I'm just going to create a new interface. You could do this by casting instead, but interfaces are slightly better. So this will be BP enemy int for interface. I'm going to just select it. Okay, so what I'm going to do from this version here is I'm going to create a bunch of just simple commands for to get the enemy's information. And as I said, this is slightly cleaner than just using a cast. So I am going to call this new function my set target widget, and it's going to have no output, so it'll be used as a input event. I'm going to have two inputs. The first will be B is targeted. Remember that B will not show up because it's a Boolean. And then I am going to do, actually I'm only going to have one. I'm going to have B is targeted. I'm going to save that. I'm going to go back to my enemy AI follow, and I'm going to go to my class settings, and I'm going to add my new interface in a BP enemy int. I'm going to compile save, go back to my event graph. This is the only part we really need to worry about in here. And in my event graph, what I'm going to do, set target widget. It's probably going to be all the way to the top. There it is. Add event. And you'll know it's getting from the interface when you see that little interface icon. I'm going to pull off of here, and I'm going to do not. So it's going to be the inverse of whatever we pass into there. And I'm going to grab my widget component here, and I'm going to set hidden in game. And we're going to propagate that to the children. And you especially need this if you're doing this in proper OOP fashion, where this is the master of all your enemy classes. Plug the execute in, and plug the not into the new hidden. All right, there we go. So that takes care of what we need to do to set everything up. Now let's take care of the meatier part of this. Let's go back to our characters. As you can see, I have a tester, and then I have the actual one I'll be using. So let me just plant that guy in the world real quick. Hit play. So it's working the same way as usual. If I hit Q, nothing happens. I totally forgot to mention, Q is the key I'm using. So go to your project settings. One key step, if you don't already have this put in, is to have an input action mapping in place. So I have a camera reset stroke lock on. And because I'm a huge Dark Souls player, yes, I use a controller, but I do know the keyboard commands, and keyboard command for that is Q. So Q will be our lock on. I've also slightly edited the camera angle, so some of the numbers I use later on, which I'll comment on, you might need to change. But that's working. Let's also still make sure that this enemy follow is still following, so let's grab this version of him, because this is the one we're working on. And he's following me. I also have added this is debugging, so we can see the debug sphere under that enemy, around that enemy when he's hunting. There you go, it's a massive sphere. We'll turn that off for now. So let's go back to our player. So let's open up our player base there. And we have all the default stuff that comes in here, right? In fact, we'll play with some of this later on. So we need to consider first what we're doing. Well, we're either locking onto a target or we are resetting the camera. And reset will bring the camera back to around this default position. So to do that, well, first thing we need to do is we need to get our action mapping. So I have camera, reset, stroke, lock on. There we go. All right. So what we want to do is we want to, if we are not targeting something, we might want to target. If there are no targets, we might want to reset the camera. Or if there are targets and we are locked on, we might want to reset the camera. Yes, those are 3 different options. Those weren't 2 the same option. So we'll start with the branch. And we want to know on this branch, are we locked on to the target? So we'll pull off of here to promote to variable. B is targeting. So are we targeting? And if, by the way, you have any disable movement stuff, you might want to add a check right here to see if movement is disabled. You might only want this to go off if the character is able to move. All right, so we're going to have 2 events. Off the true, we'll reset the camera. Off the false, we'll lock on to the target. So let's just create those events real quick. So custom event, and this will be lock on target. And I've already mentioned locked on target will come off the false. So we'll do lock on target. There we go. And we'll do a custom event reset camera. Now we're going to leave reset camera up here for a moment, mostly because that'll be the last thing we do. But let's just add this in now before we forget. So when we press the button, we're going to check, are we targeting? Or we're going to check, are we able to move? If so, are we targeting? If we are, sorry, the joys of living in a different country, I didn't realize I had done that. Yes, there are some spelling differences in American versus British English. All right, so if we are targeting, then we will reset the camera. We'll break the target and reset it. If we're not targeting, then we're going to try to lock on to a target. So we're going to actually have so that's the first part we're going to do, is we're going to try to lock on to the target. And in particular, what we want to do is we actually want to do another check at the very start of this. So at this function down here, or this event, we're going to do branch, and we're going to get our is targeting, but we're going to do is not. So we want the not boolean. We're going to plug that into there. And all again, we're checking, are we not targeting? So this is a double check. And then we're going to, if we are not targeting, we're going to clear potential targets, and then we're going to find targets. If we are targeting, so we come up with false here, we're going to reset camera. And the reason why for this double check is if we already are targeting, we just want to reset the camera, well, this is how we do that. Or this is a backup method in case for some reason this doesn't properly go off. So as I said, we're going to clear our target, and then we're going to find a new target. So we're going to start with our find targets first. And this is these 3 functions we're about to work on are the main sort of functions to make this work. So we have find targets. And as I mentioned, we'll have a clear target up there in a minute, but we'll take care of that in a moment. So the first thing we're going to do is we're going to draw our targeting area. I just had 3 functions. I think it actually is, yeah, it's 3. I don't know why I thought it was 4 for a second. I'm thinking of the debug function we're going to add in. So the first thing we're going to do is we're going to do sphere overlap actors. So anything that's in a sphere that we draw, if it is of the correct actor type, will be added to an array. So what we're going to do for our sphere position is we're going to get actor location. So this gets the location of the target actor. In this case, since we're in the player and it's self here, it's getting the target, it's getting where the player character is. So this is the center of our sphere. Around this, we're going to draw out a radius, and we're going to promote this to a variable to do so, and this will be called target area. And I'm going to quickly compile. We'll get an error message. You can ignore that. And now that I have that compiled, what I'm going to do is I'm going to set my target area to 1,000. All right. I am then going to take, this is where we're getting the error, our object type, and I am going to type in make array. And I want an array of pawns, because the character and our enemy if you think about inheritance, it goes pawn, character, whatever subclass. So player, enemy, what have you. You can see parent class of the base player is character. Go to our enemy, it's character. The parent class of character is pawn. So we want pawns, anything that falls under that area. But we want a particular pawn, and that one, and this is where you're going to put your master. In my case, I'll just be enemy AI follow. So whatever your master class is. And just because that is annoying me, I'm going to compile again. You can see it goes away. All right. So next we're going to have, this is completely optional. We're going to have a branch here. And this optional branch, what we're doing is we're going to have our own debug mode here. So debug mode, actually B, debug mode active. And this is just so if we do decide that we want to have some debugging set up for us, I'm going to make this something we can edit. We can turn this on and off as needed. We'll default it to off though. All right, and then what we're going to do is we're going to take all of this and we're going to collapse it down to a function. This will be draw targeting area. Well, I saw that before I did it. Here we go, draw targeting area. Pop open the new function we've just made. And in here, I am off the true going to draw debug sphere. And then I'm going to plug in, actually I'm going to copy both of these, my active location to center, my target area to radius, and just so you know, I know it's friendly, I'm going to turn it green. I'll leave it on screen for 5 seconds if I'm debugging with a thickness of 2. I will collapse this down to a function itself, and this will be debug, I can tell debug, right? Targeting area. All right, let's just pop that open real quick. Get rid of that, or sorry, line it up. Add in a return, if I can spell return correctly. There we go. All right. Let's close that out, we don't need it. Let's go back to this draw targeting area. And we're going to put in our return. And make sure off the false that you put in another way past that debug area. So all we're doing with this branch is checking if we are debugging. If we're not, or even if we are, we still are going to continue on to this return node. And because I am that anal retentive, I am just going to straighten those out. From our out actors, we're going to pass this out. And this will be our list of targets. All right, let's go back to our event graph. In our event graph, we are going to loop through these. In fact, we're going to create a function pretty quickly. So we're going to do a for each loop. Ooh, I just thought of something. We're going to start this for each loop, and now we're going to go back to our enemy real quick. And in here, if you don't have a Boolean called is dead, add a is dead Boolean, and then go to your interface, and we're going to do a new function, get is enemy dead, and then we'll do a b is dead Boolean, compile, save, return back to your enemy, open up the interface tabs, and then get the is enemy dead, take your is dead, and plug it into there. Now, the reason why we're creating an interface to pass on a Boolean, one, besides being good practice to use getters and setters, so here's a getter, and unfortunately we can't make this a pure getter like we could. Actually, let me just double check we can't, as I say that. No, we can't make it a pure. Nope. All right, so the reason, besides good practice of using getters and setters, we can't get this Boolean information from this array. Because this is just an array, if we open this up, of actors. So it's actors only. So is dead doesn't show up. You notice my get is enemy dead message does show up because, well, one of the classes that character inherits from is actor. So I can use that as my target for the object and get that information. In fact, actually, that's what I am going to do. So we're going to get is dead, the message. We're going to plug that into the loop body. Now, the reason why we are doing this, now in my current template game that I'm using as an example, it doesn't matter. All the enemies are alive, but if you kill an enemy, you don't want to be able to target them perhaps in your game. So this is a good way to check. Are they dead or no? If they are dead, well, we're going to do nothing. If they aren't dead, we're going to do add unique. And what we're adding is that array element. So we'll just put a reroute in there so it's a bit clear how that's working. And then off this add unique, we'll do promote to variable. And this will be our potential targets. All right, so we're going to take all of this, and we're going to collapse this down to a function. And this function will be set potential targets. All right, remember, if they are dead, so if this is true, and I'm now going to go back to my enemy to make sure the default is not true on that, thank God it isn't, then we're adding it to this list. Once we have populated our entire list, we're going to do a return node, if I can spell return correctly. That's what I get for not looking at the screen. And we're going to pass out our potential targets as what we want to carry forward. So we now have a list of potential targets, and from there we're going to select our target. So, again, we're going to draw a for each loop, plug that into the execute. And this one, we're just going to take the single node right now and collapse a function. And this will be select target. And this will be our potential targets still, because we haven't actually set our target. Let's pop that open. Let's expand that out a bit. And I know I'm going to want some reroutes in here, because I'm going to put something before we do that. So I'm just going to drag those down here. I am going to get our targeting area. I'm going to get it, pull from it, promote to local variable. And this will be my distance local. So what this is going to do, let's say you have multiple targets. We have an array, so we can store multiple targets. Yay! But let's say you have multiple targets and you only want to target one of the enemies. Well, how do you pick? Is it the first that gets added to the array? Well, actually, probably so in this case. That's how this is set up. But we want to do it instead based on how far the target is from the player. So the nearest target is the one that will get passed out as the potential target. Or sorry, as the selected target, not potential target. So all potential targets have to have their distances checked. However, the first target tested is not going to have anything to be compared against. So what we're doing here in this set local, or set distance local, is we are going to, every time we call this function, set our distance local to the same as our targeting distance. So we know the enemy is going to be within the targeting distance, so we're just literally adding it to this list. All right, so to do that, well, what we're going to do is we want to get the distance between the player and the target. Well, there's a get distance to node. And so we're just going to move that to other actor. It doesn't really matter. You could do this in any order. It's going to be the same. So we want to know the distance between the player, so self in this case, because we're in the player, and the target that it's looking at in this array. We then want to know, is this distance less than our distance local? All right, so the first one comes through. It has to be less than our distance local if it's in the list, because if it's greater than the distance local, it wouldn't be put in the list. So that will return a true. So let's put a branch in here. If that is true, so when again on the first player or first target, it's going to be less than 1,000 automatically. We want to take this and promote it to a variable, not local, and this will be our selected enemy. And notice that it's an actor class. So again, we have to use those interfaces or cast. So there we go. We can plug that into there. In fact, to make this a little bit easier to read, let's put those reroutes in. Line those up a bit better. All right. Also, what we want to do. So this would work if we only had one person. because the distance local is always going to be 1,000. It's always going to be less than, so it's always going to set that person. What we want to do is we want to update the distance local. So we're going to break that for a moment. We're going to take our distance local and we're going to set it here. There we go. And we're going to plug that back into there. And we're going to come off this return value on the get distance 2 and plug that into there. Again, a couple of reroutes just to make this a little bit easier to read. Alright, so to walk you through this, we have our list of enemies. We set our distance to 1,000 to start. We start this loop. It checks the first enemy. Well, the first enemy is going to be less than 1,000, so this is true. We set the distance to whatever that value is, so let's say it's 900, and then we set that as a selected enemy. It goes to the next item in the array, and it goes, well, this target is only 800 away. Well, 800 is smaller than 900, and it goes true. And it sets this to 800 and makes the second enemy in the array our selected target. It gets to the third, it finds the distance is 850. It goes, well, 850 isn't less than 800, so false. And then it goes to the fourth, and it goes, the fourth is only 200 away. Well, 200 is definitely less than 800, so we set the new distance to 200, and the selected enemy to that fourth element in the array. And let's say we only had 4 enemies. Well, that's the one that's going to be the selected target. And then we do our return node off of here. So let's just, again, put some comments in on this. So this first, I'm not sure what's going on with my keyboard here. There we go. The first one is each time function is called set initial distance to the max scan area. This is just so we have a value in there that is reasonable and we know our target's going to be within. Then we want to find, so all of this is find closest target and set this to selected enemy. And the way this works, I'm just going to expand that out a tiny bit, is we want to set distance based on which target is closer to player. So that's what all of this does. Next, we're going to grab that and we're going to do is new distance less than old distance. And these comments are optional. They're completely up to you. They're just to help explain what is happening here. There we go. So that takes care of our actual selecting of the target. So now that we've drawn our target area, we have made sure that target is still alive. We now have selected the closest target to be our enemy. What we're going to do is we're going to get our selected target. And we are going to right-click selected target and convert to validated get. Plug that into there. Now, alternatively, what you could do is take your selected target, pull off of this, and do is valid with the question mark. These two things are essentially doing the same thing. In fact, we'll actually use this later on, just because for some reason I prefer it there. But here, this is fine. Now, we are going to, on the is not valid, so we didn't find a valid target, we're going to reset camera. Again, that'll be the last thing we actually do. I'm not sure why that just randomly jumped out to the side like that. And the step after that is we're actually going to lock on to that target. So we're going to create a custom event again, and we're going to lock on. All right, let's just leave that there for a moment. Let's make sure to plug this lock on there. And for those of you still remembering, yes, we have that clear that we have to do, and then we do the find target. So I'll add that in a moment as well. When we lock on, what we're going to do is we're going to take our is targeting. Oops, not the get. We're going to set is targeting. Plug that into there. We're going to get our camera, we're going to set our camera mode to locked. So we're going to create a new boolean for this. And that will be camera is locked. Just line that back up. And we're going to set our camera is locked based on our is targeting. Now, as I mentioned earlier, you could cast. You could do a cast event off your selected enemy and then get the set target widget. Remember, our set target widget, if we go back to our event graph, is what makes the lock-on component visible. Well, casting can be costly, and a very efficient way of doing it, it's still somewhat costly because it still is copying information, but it's not copying it every single time, is to use an interface message. So we'll do set target widget off our selected enemy. You want the one that says message. So it should have a little open envelope there. And we're going to pass in this information to the is targeted. Remember, when it comes through on the enemy AI, or the enemy pawn, because it really isn't the AI, it's the pawn, we will be setting it to not hidden at this point. And I mentioned the inverse earlier, and again, the reason for that inverse is new hidden, saying is this basically is hidden or not hidden. If they are targeting, this is true. If we plug that directly into there, then we're saying hide this. So really what this is doing is converting the two booleans are inverse of each other. So all we're doing is we're converting it from one method to another. It has the same meaning at the end of the day. All right, so we have locked on to the target. So if we were to pause and just test it here, let's see what happens. I thought I hit play. I did. It was in the other window. There we are. There's our guy following us. I hit Q. Well, nothing seems to be happening, so give me 1 second. Let me just move this over here and pop that back open. Yeah, funny part is, I said we are going to do X, Y, Z, and then we will come back and fill this part in. That's why it's not working. And the next best part of about that is when I was testing this, I made the same mistake. I was like, why isn't this working? I came back in here, and I was like, oh, yeah. So, all right, let's first take care of our clear, because we need to clear our list. So we're going to get our potential targets, and we're going to clear. Just plug that into there. And let's make a very simple function for this by selecting those and doing collapse of function and set this to clear potential targets. All right, so from our clear potential targets, we are then going to do our find targets. All right, now we can test it. The is targeting for some reason came back up as default as true. I'm not sure why that happened. Try that one more time. There we are. You can see the little red dot for our targeting widget. Now, notice the camera still moves around. I'm still free to look as I want. I'm not locked on in that truest sense, and I can't get rid of the targeting because we haven't done the reset camera. So first thing we're going to do is we're going to make the targeting just slightly better. So let's go back up to where our lock on is first called. We are going to set timer by event. This will be a looping event that will loop every half second. And we're going to take off here, promote that to a variable, and this will be range check timer handle. All right, let's create our event. So this will be a custom event. Check if in range. All right, and I'm going to be a bit cheeky about this. I'm going to not go into potential targets. I'm going to go into select target. And I'm going to take this branch for a moment. I'm going to go back to our event graph. I'm going to paste that in there. I don't need that, and I don't need the comment. In fact, actually, I didn't need that either. It's going to be greater than. And then our selected target. So get the distance between the player and the selected target. And I'm going to have a branch here. Let's just take that. Take all of this, move it under here. Plug that in. Then take these nodes minus the branch, collapse to function. Check if target is out of range. It is a pure function, and B is out of range. All right, so now we have a simple function to check if the target is in range or not. I really wish it would copy over a bit nicer, but whatevs. All right, yeah, I know. Let's take care of that error. The I know is that error, and we're going to create event. And the event we're going to do is check if in range. All right, so if you want to be really pedantic, what you would do at this point is put print strings in. So print out of range, or sorry, print, yeah, out of range. print in range and test it. I've already tested it, so I'm not going to go through that step. But what I am going to do is, if this is true, if the target is out of range, I am going to reset the camera. And now I have a paranoid moment where I just want to double check I've done. Yeah, it's not right. I skipped a step. So, right now it's saying if the target is not 0 Unreal units away, then it's out of range. We're going to set the range to our targeting area, which is why I made that a variable. So, is it closer? Is it closer than 1,000 Unreal units? If it is, then it's in range. If it is not, so if it is out of range, so it's a little bit easier to read. If it is out of range, then we are going to reset the camera, which again we haven't taken care of yet, and we are going to clear and invalidate our range check timer handle. If it is valid, so in other words, they are still within range, and we're going to do nothing. Let's test that out. All right, there's my little dot. Well, he's still moving around freely. He's going back to his check location. He'll spot me again. Notice the dot's still there, so we haven't done the reset camera. Notice I can still move my camera freely. So let's take care of that last little bit and test it one more time before we finish this out. And what we're going to do is we are going to set some events based on the fact that our camera is locked. All right, so what we want to do, and you can do this either in the mouse input version or the gamepad version. I've done it on both. I've done them independently on one, and I've done it on the gamepad version, and been able to get it to work even on a mouse without that running, but we'll just take the mouse version. We care about the turn rate more than the lookup rate. So what we're going to do, we're just going to, no, we're going to move this just so we have, really? Okay. If that's how you want to play things, Unreal, we're going to just move this so we have a bit of room to play with, because, yeah, I can eat up space real quick. We don't care about the lookup, so we're just going to move that down there. We do care about this one. We're going to put a branch in here. And just so that it goes along the true, because I like the primary events being on the true, we're going to take the camera is locked. We're going to do not. And we're going to plug that into the condition. So if the camera is not locked, we can still do what it normally do. If it is locked, then we're going to use a new function. And all I'm going to do real quick is to start this up is do is targeting, and this is just another check. This is also useful if you have other reasons the camera might get locked besides targeting. And we're going to collapse that down to a function. This is going to be our lock camera. In my head, that's short for lock camera on target. So are we targeting? If we are, then what we're going to do is we're going to get controller. If I can spell controller right. And we want get controller, the pawn function. We don't want get player controller. We're going to set control rotation. There we go. Plug that into the true. All right, so what are we rotating to? Well, we're rotating the player camera. Here, because we don't have a rotation in yet. So we're rotating the player's camera towards the enemy. So the way we do that is, well, first we need to get where the player camera is. So we're going to get player camera manager. We are then going to find its look at direction. Well, actually, not even its look at direction. We just need its location, because its location tells us which way it's turned, so we know which way it's looking. And now we can find the look at rotation. So find look at rotation. So we know where we're starting from, our player camera. We know where we want to end, our target. So we're going to take our selected target, and we're going to get actor location. So we start at the player camera, and we end at our target. And we're going to want to break this. And the reason why we're breaking this is we don't really want to change the pitch based on the enemy. You might want to. If it's a really tall enemy, you might want the camera to angle up, and you might set that differently. But for now, with roughly the same size, we don't. And we're going to do a make rotate, not make noise, make rotator. Okay, I'm not sure why I can't find make rotator unless I'm blind. There we go. Make rotator. Oh, I see what I've done wrong. Sorry. This will be break rotator, not into accesses. That's why I couldn't get it to work. We're going to plug the X into the X and the Z into the Z. And for our Y element, or our pitch, we're going to do is minus, so float minus float. Now you could do plus and just make it a negative number. And again, based on your camera angle, you might want to change this number. I tend to leave it at less than 25. In this case, I'll be using 5. All right, so let's go back to our event graph. So if we test this out now, I can't move the camera, and you notice that as I move around him, it does that thing of just slightly jerking to follow him. As I move farther away, well, I'm still targeting because we haven't dealt with the break rotate, the end of our lock-on, our reset. So let's take care of that last little bit, our reset. And I'm going to be a bit cheeky. I'm going to grab all of this, and I'm going to Control W it down here. And I'm just going to set that to false. I'm going to remove those two and just place them there for now. So we are no longer targeting. Camera is no longer locked. So if we test it now, I'd be able to move the camera again. But I want to reset the position. So what I'm going to do is I'm going to get the controller, and the position of the camera, that is. And I'm going to set control rotation. Plug that into there. From the control rotation, I am going to make rotator -20 in the pitch. And that's just because of my settings for the camera I used here. You might need a different one. I'm going to do get actor rotation. And I don't need to break it. I'm just going to split it. Plug that into there. Plug that into there. There we go. All right, so now when it resets, the camera will automatically go back to this default position. Now, we still have all that targeting information. We still have the little thing showing up. We still have everything else related to it going on. So instead of using a validated get, I'm going to use that is valid from earlier. Again, I could use a validated get. I just, for some reason, prefer the is valid check here. So if it is valid, then I want to get rid of that little widget. I also want to clear my selected target. So I'm just going to set it and plug nothing in. And in case that timer handle is still going, I am going to clear and invalidate that timer handle. I forgot that on my test. All right. So now everything should be working. We're in our world. I'm locked on. He's following me because that's what he's programmed to do. My camera's following him. One version of this, ooh, he got far enough away that it broke the camera lock. The reason why I added this, by the way, was because he used to chase me in such a way that he would follow me off without the nav input saying you can jump off the top of this thing. Oh, I think if he's close enough, he'll do it. There we go. But as you can tell, if I hit Q again, I have camera movement back. The red dot's gone. I hit Q again. And this time, let's get out of range. See, I'm out of range. The dot's gone. I'm able to move the camera freely. Hey, buddy. Well, he's stuck there due to the nav meshes. But as you can see, our targeting system, assuming I don't run off the edge there, works quite well. And you can replace that red dot, of course, with any sort of HUD element you want. So, you know, white circle, crosshairs, what have you, just so long as there's a transparency to it. You can also add multiple targeting elements to a character if you want, and have it target based on the nearest component on that enemy, have it target based on the component that will do the most damage, so weak spots, or the reverse on its heavy armored points, what have you. But you can mess around it with it any way you like. So hopefully this video hasn't been too long. but that is the entire coverage of our targeting system. All of that said, I'd want to give a big shout out to my Patreon sponsors, and I look forward to seeing you in the next tutorial. I should be starting the RTS series back up shortly. And as always, I hope that you have a wonderful day.